Hello, I'm Josh.
I'm Taylor.
And I'm Ryan.
We have been studying the effects of ozone in different areas, but to understand our experiment, you must first understand ozone.
Ozone, or O3, is 3 oxygen molecules bonded together. It is normally found in the stratosphere and is helpful because it reflects harmful UV rays. However, when it is found at lower elevation, it can be very harmful because it traps the UV instead of reflecting it. It is one of the most common pollutants produced and is becoming a large problem.
Estes Park and Rocky Mountain National Park have such high levels of ozone because they are located above the large cities of Denver, Boulder, Longmont, Fort Collins, and Loveland. All of the pollution from these cities travels upward and is trapped by the mountains, in other words, Estes and the National Park.
Our experiment is to compare Estes Park to Rifle, a Colorado city on the opposite side of the Continental Divide, and to Boulder, one of the large cities causing the problem in the first place. We will be using data from the GEO3 project, which uses data from schools all around the world.
The Rocky Mountain National Park has also been collecting ozone data. We consulted a Rocky Mountain ranger about the effects ozone is having on the park.
My name is Jim Cheatham. I'm the biologist for air, water, and vegetation at Rocky Mountain National Park. I understand you guys have some questions for me about air quality today.
Yes. Have you seen any effects of ground level ozone in the national park? And if so, what are they?
We have. As many people may be familiar with, ground level ozone can be a human health concern, and so we monitor those levels, and above a certain level we issue a human health advisory, and so that's given to the visitors in the park just for their information and safety. The other item that people may be surprised with, that ground level ozone can also impact vegetation in the park. We have ongoing research that suggests it can burn the leaves of sensitive species. For example, spreading dogbane, cutleaf coneflower, and quaking aspen.
What are some of the causes of this ozone in the park?
Well, the causes are larger than the park, come from outside the park primarily. If you're familiar, it takes volatile organic compounds and nitrogen oxides from burning fossil fuels, for example, in your what's the emissions coming out of your tailpipes. And so there are many of those on the Front Range and beyond, and so combine those with sunlight, forms ozone, and the right weather pattern can push it up into the park and have these impacts we're talking about.
All right. What do you think are some solutions to this ozone problem?
Well, I think educating yourself on how you can minimize your production of volatile organic compounds and nitrogen oxides. And one of the ways to do that is to go to the state's website. There's some very good information on there. It's specifically the Colorado Department of Health and Environment, and they have an ozone reduction initiative that has a lot of good tips on how the individuals can participate. One of the examples would be filling your car's gasoline tank in the evenings instead of midday when it is hot. That helps to minimize emissions of the volatile organic compounds we're talking about. And also minimizing your vehicle miles traveled can help that as well.
Do you have any thoughts or comments on the ozone impact?
Well, I think in cooperation with the state, we can be successful in minimizing ozone levels, unnatural ozone levels in the park. And through the podcast that you guys are generating, this is yet another venue to get good information out there. So thank you for doing that. Other thoughts that I would add would be that the practices to minimize ozone can also better protect the park for other air quality issues. For example, visibility, increasing the visibility or managing for the natural level of visibility, and also reducing atmospheric nitrogen deposition that can also impact the natural resources in the park. So thanks for doing this.
All right. Well, thank you for your time, Jim.
Thank you. Thanks. Sure.
Josh, our partner, has been pulling data off of the GEO3 website and was able to construct a graph based on the relationships of the Estes, Rifle, and Boulder ozone. This graph shows that when Boulder ozone, measured in parts per million, drops, the Estes ozone rises. Estes ozone may have skyrocketed because of the fire around that time period, or because at the start of the summer, tourists begin arriving. These graphs show that the ozone in Estes increases when the ozone in Boulder decreases, while Rifle stays high. All of the locations have about the same high point in ozone level.
From my data, we can conclude that Rifle had the overall highest ground ozone levels, possibly because it is located between mountains which trap in the ozone.
On the other hand, while Boulder and Estes Park have, on average, the same amount of ground ozone, the ground ozone levels peak and drop at different times.
Overall, we can conclude that the continental divide and the Rocky Mountains greatly affect the amount of ozone in this region.